Hi, welcome back to Moose and Chemistry. This is a phase diagram for water lesson A. So what we're going to do today, we're just going to draw the phase diagram. Now, the phase diagram is pretty easy to read, and it has a lot to do with different phases of water at different temperatures and pressures. So let's go ahead and draw ourselves a kind of a graph there. All right, now, so what we're going to do is we're going to kind of set the graph up. And we're going to be talking about certain points like triple point, critical temperature, for example, normal boiling point, normal freezing point. All right, so anyway, let's go ahead and put this together. So we're going to draw this, let's see here. So we're going to say that this is atmospheres and pressure. We'll call this pressures on this side. And it's going to be in ATM. And down here we're going to use temperature. I know we've been doing a lot of Kelvin, but here we're going to be using temperature. And that's going to be in degrees C. Okay, so now let's go ahead and set ourselves up a diagram here. And we'll use this point as 0. All right, and then we're going to have a point here. We're going to go 0.0060. Then we're going to have 1 ATM here. Okay. And then we're going to go all the way up to this point here, which would be 217.75. Of course, these are in ATMs. Okay. All right. Now, so what we're going to do is we're going to put our first thing out here as 0.00 degrees C. We're going to come out here to make this 100 degrees C. Let's make that a little bit better because we want this readable here. And then out here we're going to come way out here, and we're going to make this like 373.99 degrees. And this is of course C. Just to kind of give you a hint there. All right, so what we're going to do is we're going to set up our chart, and we're going to make a dotted line going this way. Again, different substances have different phase diagrams. Okay, so now we're talking about water here, and this right here at 1 ATM at 100 degrees Celsius is called the normal boiling point. So normally at 1 ATM at 100 degrees Celsius, water, the bonds break and it begins to boil. Okay, so now we're going to come over here. And we're going to come up here. And we're going to make another point here on the phase diagram. Now that point is going to be called the critical point. Now, what the critical point basically tells us is that it's the temperature at which above which the substance cannot exist in a liquid, no matter how much pressure you put under it. So water at 217.75 atmospheres at 373.99 degrees Celsius cannot remain as a liquid. So at that critical point, no matter how much pressure we put on it, it's going to turn into a gas. That's what this means. All right. So now, at 0 degrees Celsius, at 1 atmosphere, we have something called the normal freezing point. So at 1 atmosphere at 0 degrees Celsius, water is going to freeze. Okay. So now, here we go. We're going to go and do this one next, which is going to be right here. And I want to make a line down here and make this 0.01 degrees C. So we're going to come up here. And this is going to be called 0.060 atmosphere. This is called the triple point. Now, what is the triple point? Well, the triple point is where substance indicates the temperature and pressure at which it can be a liquid, a solid, or a gas. It can coexist at equilibrium at the same time. Okay, so now let's look at these different states. Okay, so we're going to draw a line, and we're going to connect a couple dots here. So let's see here. All right, so we're going to go from here to here to there. So now, and remember, we're going to come up here at 0 degrees Celsius, right below 0 degrees Celsius. This is called point D, and this is the critical pressure. Okay, this is called critical pressure. All right, now what we're going to do is we're going to say from point D, and we're going to label this point A for argument's sakes. So we're going to draw a line that goes through all of this here, and out like that. So if you're in this area, and let me change the color here. That's what we can do. Let's change the color. Yeah. Let's make this, I don't know. Whoops, that's not what I want to do. Uh-oh. Well, that kind of was embarrassing. Let's change the color here. Yeah, that's it. All right, so now let's try that. Wow, that was pretty cool. So now, anyway, if you're in this area, your temperature or pressure lies in this area, you are going to be in the solid phase. So your substance, your water, is going to be solid. Okay, so now let's do a different color here. I like to do this. So yeah, lots of cool colors, huh? Let's do fuchsia. That'd be cool. So if we're in this area here, right? You're in this area here. Your substance is going to normally be a liquid. So let me go ahead and change colors here again. Thank you. Let's go to blue. Yeah, that's good. So here, this is always going to be a liquid. So if your temperatures and pressures lie within that purple area, you're always going to be a liquid. Last but not least, let's do this one more time. Let's get a good green in here. Okay, so if you are in this area, your temperatures and pressures lie within that area, guess what? You're going to be a vapor. That means you're going to be a gas. That doesn't look too good. Let's make that a little bit, change the color there. So let's change the color, make that a little bit better. What do you say? Huh, okay, let's do this yellow here. Okay, so good. So you're going to be a gas in the state, which is going to be basically a vapor. You're going to be a vapor. All right, so now, pressure and temperature affect the states of water. If you have low temperature, low and semi-low pressure to high pressure, it's going to remain ice. If you're going to have low temperature, low pressure, you're going to be a solid. You could be a solid, liquid, or gas. And then, of course, as the temperature increases, as the pressure increases, so does the chance of that liquid turning into a vapor. Well, that's it for today's lesson. Guys, you be snarly, and we'll see you back here at Moose and Chemistry.